derivative, differentiation, partial differentiation, partial derivative, partial derivative along a vector. Okay, so differentiation, derivative, partial derivative, partial derivative along a vector. Okay, so what are we talking about? So what is a kind of partial derivative along a vector? Single dimension, multivariate partial derivative along a vector. Okay, I mean, this is not very complex. Things will come even more interesting. So rather we can say this is not the most interesting, more interesting thing will come. Okay, so we will visit kind of what is differentiation. Now I have an independent variable x. Okay, now since x is independent variable, x would vary, and there is a function over x called fx. If fx is function over independent variable x, means as per the x varies for different value of x, we have different value of fx. So there is a function over x, or in Python terms, there is a function which takes parameter as x and it returns a different value, or we can say y equal to fx. Okay, so if x is 3, then fx is 9. If x is, if, or I can go even beyond, if x is 3, fx is 27. If x is 2, fx is 8. If x is 4, then fx is 64. I mean, no, it's a kind of someone can estimate. So if x is independent variable, then fx is x cube. So this is single dimension. This is x-axis. This is one axis. Along this axis, x varies. So if x is 2, then fx is 8. 2 into 2 into 2. If fx is 3, then fx is 27. If x is 4, then fx is 64. 4 is a 4 is a 4. It will become 64. So if x varies unit by unit, then fx varies to the power 3 of that unit. So now y equal to x cube. Okay, so this is, now if I draw the graph, this is not a linear equation. Okay, so this is a kind of polynomial equation. Now, so if this is x-axis, then graph would be something like this. Okay, if this is x-axis, then it would move like an aeroplane. Okay, so at 1 it is 1, then 8, then 27, then 64. It will go like this. It will go like this. Okay. Now, what is differentiation? If there is variation of 1 unit in x, then how much unit is the variation in y? If there is variation of 1 unit in x, then how much there is variation in y? How many unit y would vary? dy by dx. f dash f da- f dash x dy by dx. Per unit change of x brings how many change of how many unit change in y? How many unit of change in y? dy by dx. So if there is a point called alpha, then dy by dx at alpha is how much? So that is 3 alpha square. So at a point, at a value of x alpha, x where x is alpha, then dy by dx at x equal to alpha is 3 alpha square, means dy by dx at any x is 3x square. So if x changes 1 unit, then y changes 3 into 1 square. If x changes delta alpha, if x changes or x changes delta x, then y would change 3 delta x square. So one is equation, that is y equal to x cube, fx equal to x cube, and there is a dy by dx equal to 3x square. Means for each unit of change in x, y would change 3x square. So this is derivative. Okay. Now we know that. So what is the direction? Direction of the derivative. Okay. So it is also called gradient. So gradient typically at any moment. So if this is the graph, at any moment, at any x, gradient would be, it is kind of slope. This is what we see, the rate of change. Rate of change means it is slope. So at that point, if I take a point as alpha, at alpha it is 3 alpha square. So alpha is 2, means 3 into 2 square. So it would be 12. So at that point, if x is 2, then y is 8. But if x is 2, the rate of change, if x changes 1 unit, then y would change 12 units at that moment. So rate of change in y is not linear. If x is 3, then 3x cube means 3x square, means 3 into 3, 9 into 3, 27. So now when x is 3, at that moment per unit change in x, y would change 27. If x is 4, then y is 64. Whereas if x is 4, then 3x square means 1648. So the rate of change that is seen in y per unit change in x when x is 4 is 48. Okay, so this is dy by dx. This is derivative. Derivative means how much y would change if there is 1 unit of change in x. For 1 unit of change in x brings how many unit of change in y, that is dy by dx. Dy by dx, if I am saying like this, it means what we are trying to calculate. Suppose at any x, what we are trying to calculate is f x plus delta x. Now at any x, if there is a change of delta x unit, I won't say delta x unit. One unit can be anything, 1 millisecond, 1 millimeter, 1 micrometer, 1 nanometer, whatever. If there is a delta x unit of change at a point x, okay, then what we are trying to say is dy by dx equal to f x plus delta. What is the value of function when x at x plus delta x? Minus fx by delta x. Per unit change in x brings how many unit of change in y? If there are delta x unit of change at x, then fx plus delta x, f bracket x plus delta x, at that point what is the fx? Minus fx by number of unit is delta x. So, or what is the change? What is the change in y seen at a point called alpha when there is a change in delta alpha of unit? So f alpha plus delta alpha minus f alpha by delta alpha. So if I divide by delta alpha, then per delta alpha unit, how much function would change? So that is dy by dx, where x equal to alpha. So then we know that how much it is changing for delta alpha, then f alpha plus delta alpha minus f alpha by delta alpha. So per delta alpha of unit of change, how much y is changing. This gives you per unit of change how much y would change at when x equal to alpha. So this is the derivative of y equal to fx, where at any point x. So that is, we know how to calculate the derivative. Now let's consider we have two independent variables, x and y. If there are two independent variables, then x is in this direction, then y is in this direction. So this constitutes a plane. Sorry. So earlier we had a line. We have a line. Now we have a plane. So independent variable would vary over a plane where each point in a plane has x and y. X is x-axis and y is y-axis. This is positive direction. If that is the case, then we have a function fx that is orthogonal to x and y, that would be z in this direction, x in this direction, y in this direction, then z in this direction. Now z equal to fxy. Earlier y was fx, now z equal to fxy. If that is true, then fxy is nothing but a function over two varying independent variable x and y. If that is the case, then what is partial derivative? Okay, let's consider that our fxy is 1 minus x square minus y square. That is equation of a circle. X square plus y square, x square y square. This is equation of a circle. So if I have a plane like this, then on this plane, okay, x, y are confined to a circle. Okay, so x, y are confined to a circle. If x, y are confined to a circle, then z equal to 1 minus x square minus y square. Means when x and y are 0, z is 1. When x is 1 and y is 0, z is 0. When y is 1 and x is 0, z is 0 again. This constitutes a sphere where the independent variable are varying in xy plane, whereas z is varying in the vertical direction, and it makes a complete sphere. At the center, z is 1. Okay, whereas when x is 1 and y is 0, z is 0. So it is a sphere. In that direction, when y is 1, x is 0, z is 0. Left side, if I go, then x is minus 1, y is 0, then z is 0 again. So this proves that z is a sphere, whereas xy is a circle on a plane. So if we move in a xy plane, dot by dot dot dot, it constitutes a vertical area that is a sphere. So z equal to 1 minus x square minus y square. So this is, now can we calculate how much z would vary in x direction? If I keep y constant, any constant, y is 0, y is alpha, y is b, okay, and then if I move along x axis, how much z is vertical, so vertical, how much z is vary. If I move 1 unit in x direction when y is fixed, then how much z would move? Okay, so this is dz by dx provided y is constant. So if I calculate, so this is partial derivative. Okay, partial derivative means two multivariable case, multivariate case, where we have two independent variable and one dependent variable, that is fxy, that is z. How much dependent variable, that is vertical, how much z would vary per unit change in one of the independent variable. If I say dz by dx or fx xy, then it is dz by dx. So if it is 1 minus x square minus y square, then it would come as minus 2x. So every change, 1 unit change in x direction would bring minus 2 change in minus 2x. So at 1 unit change in x direction at any point alpha would bring minus 2 alpha change in z. Okay, dz by dy provided x is constant would bring minus 2y in y direction. So dz by dy where y equal to beta, then dz by dy at y equal to beta per unit change of y at y equal to beta would bring minus 2 beta change in z. Okay, how we calculate this? So derivative, partial derivative in x direction would be, okay, so f x plus delta x comma y minus fxy by delta x. So if I have delta x unit of change, then fxy would change fx plus delta x comma y f x plus delta x comma y bracket close, because y is constant. I can say at y is b, then fx plus delta x comma b minus fxb by delta x. So this is the partial derivative of fxy with x. Now partial derivative of fxy with y or in the direction of y or in the direction of j. Partial derivative of fxy in the direction of I vector. I is a unit vector, that is x axis. J is a unit vector, that is y axis. So how much is the partial derivative of unit vector in I direction, and in what is the partial derivative of fxy, that is z, in I direction and in j direction. So in I direction, fx plus delta xy minus fxy by delta x. In j direction, fxy plus delta y minus fxy by delta y. So now we know that how much a function fxy varies along, varies means dz by dx. So how much fxy varies along x-axis if there is a 1 unit change in x. How much fxy changes along y direction if there is 1 unit of change in y. Means how I can understand it more. Suppose there is a equation z equal to 1 minus x minus 1 minus x plus y, or simply I can say minus x plus y. So z equal to minus x plus y. This proves that if I calculate dz by dx, it is minus 1. dz by dy, it is 1. So if this is x-axis, so this is like this. So along the, if x is growing, z is decreasing, whereas it is like this from my side. Okay, so this is y-axis, this is x-axis. So as x is growing, z is decreasing, but as y is growing, z is increasing. This is a typical different kind of, or if I can show like this, then if x is decreasing, if x is increasing, then z is decreasing. If I consider this as positive y, then if y is increasing, then z is increasing. So minus x plus y is another equation of a plane, another equation of a 3D, where if x is increasing, z is decreasing. So this is the xy plane. Over xy plane, I have a kind of 3D plane where x is decreasing, increasing, z is decreasing. Now it is tilted. X is decreasing, z is decreasing, but it is tilted along y axis. If y is increasing, z is also increasing. This is a peculiar case. Now, if I calculate dz by dx, it will be negative, whereas dz by dy, it is positive. So this is partial derivative along I-axis, unit vector I and unit vector j. This is how we calculate, keeping one as constant. Or if I say fxy equal to xqy, then dz by dx is 3x square y in one direction, and then just xq in one direction. If it is xqy, 3x square y in I direction and xq in z direction. Now calculation, what we want is, if we know partial derivative along I-axis and z-axis, what is partial derivative of fxy along any vector u? We calculated partial derivative along I-axis, partial derivative along z-axis. What is partial derivative of fxy along any vector u. Okay, so can we proceed on this? Okay, small hint we can give. So it is like, so it will be if there is a change. Okay, so now we can say what we want is fx plus delta x comma y, fx plus delta x comma y plus delta y minus fxy by delta x delta y. We cannot say. So let's say that along u we are moving r. U is a direction. There we are moving delta u. Consider delta u. So what is change in z? So there is any vector u. We had vector I and j. There is any vector u, and in any vector u, there is a variation delta u. Okay, if there is a variation delta u, then what is variation delta z? dz by du. This is what we want. If dz by du we want, then what we are trying to calculate is f f x f, or if I say fu plus delta u minus fu by delta u. Okay, so function over unit vector u plus delta u minus fu by delta u, or if there is any point a and b on u is a unit vector in any direction. If there is a point a and b on unit vector u, so if there is a delta u we are crossing, then delta u's component in x axis, delta u component in y axis. Okay, so what we are trying to say is fa plus delta u x comma b plus delta u y minus fab by delta u. F a b is a comma b is a any point on unit vector u. Then f a plus delta u x comma b plus delta u y bracket close minus fab by delta u. So this is dz by du, d delta z by delta u, variation in z per unit variation in delta u in the along the unit vector u. So question is, if I know variation of z along I axis, that is partial derivative along I axis, if I know variation of z, partial derivative of z along z axis, what is the partial derivative of z along any direction, that is u? That is the question. dz by du. Okay, at if a and b are a point on in direction of u, then fa plus delta ux comma b plus delta uy bracket close minus fab by delta u. Okay, so start calculating.